All right, y'all. Hi, hello, and welcome to your probability quiz review. This looks very, very, very similar to the questions that are going to show up on your quiz. So please make sure that if you have questions, you ask them, and as you work through these, you are checking your answers. So to start off with this one, we're going to start off with visualizing probability first. Reminder that probability is just the chance an event will occur. Okay, it's the chance an event will occur. It's our best way to predict when something or if something is going to happen. Okay, so this one says a group of 30 people were asked to respond to the question, what is your favorite ice cream flavor, chocolate or vanilla? 12 people said vanilla, 8 people said chocolate, 7 people said both, and 3 people said none. Okay, so I always start with what my total is. A group of 30 people, that has to be my total. So my total is 30 total people. Okay, what is your favorite ice cream flavor? 12 people said vanilla. So event A is vanilla, and there's 12 people. Okay, there are 12 people that said vanilla and only vanilla. Event B is chocolate. And there are 8 people that said chocolate. 7 people said both. This is our shared event, both chocolate and vanilla. So 7 said that. And then not included, 3 people said none. They don't like chocolate or vanilla. Okay? So event A is our people who like vanilla. Event B is people who like chocolate. Event C is those that like both. And then event D is anything on the outside. Okay, that's not included. So I guess we can just call this our non or not included group. Okay, so in event A for vanilla, I have 12 people. In event B for chocolate, I have 8 people. Shared, I have 7, and I have 3 that are not included. So to me, this just makes it a little bit easier to see how many people we have in each category. Let's use that to answer some of the questions on the bottom. This says, what is the probability of event A? Okay, well, I know if I'm looking for just a simple event, because this is a single event, I know it's always going to be my type over total. Okay, so for this, event A is vanilla over total. My vanilla, I have 12. My total is 30, so that's going to be 12 out of 30, which will simplify to, let me grab a calculator so I can make sure I reduce fractions correctly. 12 out of 30 reduces down to, oh, you can't see that, can you? Me putting it closer is not helping. But it reduces to 2 out of 5. If you plug it into your calculator, and if you could see it, it reduces to 2 out of 5. Okay, probability of event B. Well, again, type over total. I have 8 out of my total of 30. So 8 chocolate out of a total of 30 people who responded. So if I pop that into my calculator to reduce it, I'll get 4 out of 15. Okay, either one is correct. You just typically see it in its most reduced version. What is the probability of event C? Well, event C is the shared one, so 7 out of 30. 7 out of 30 doesn't reduce at all, so I'm left with 7 out of 30. What is the probability of event A and B? Well, the probability of event A is 12. The probability of event B is 8, and it's all out of our total of 30. So this would end up being 20 out of 30, which reduces down to 2/3. Event A and B, that means 12 in event A, 8 in event B, add them together to get your type out of total. What is the probability of not event C? Of not event C. So what that's really asking us is, what is the probability of A plus B plus D? So what's everything but event C? We still know our total is 30. I could do 12 plus 8 plus 3 here, so 12 plus 8 plus 3. I could add all of the ones that C is not. That would give me 23 out of 30. Or I could also do 30 minus 7, so your total minus the one you don't need. That would also get you 23 out of 30. Either way is correct. You're looking for not event C. So every other event but C. Okay? This Venn diagrams help us with our simple probability. Tree diagrams help us with our compound or independent probability. Okay? It says Daniela had a choice of what she wants to wear today. She can wear her polo or her button down. Over that, she can wear her Heights hoodie or her blazer. With that, she can wear her Vans or her Nikes. Draw a tree diagram to represent the situation. Okay, well, her first choice here is the top that she's wearing. Her first choice here is the top that she's wearing. She can wear her polo or she can wear her button down. I'm just going to write button. Okay, she can wear a polo or she can wear her button down. The next choice she has is her jacket. Okay, the next choice she has is her jacket. She can either wear her hoodie, we'll call that H, or she can wear her blazer. We can call that B. Okay, that is also true for the button down. The only two jacket choices she has are her hoodie and her blazer. Then finally, her last choice is her shoe choice. For her shoes, she can choose her Vans or her Nikes. For her shoes, she can choose her Vans or her Nikes. Those are her only two options, no matter what shirt or jacket she chooses. Okay, so you can see how our options get more and more the more choices that we add. I have 2 choices for tops here. I have 2 total choices for jackets, and I have 2 total choices for shoes. Okay, our question down here is, how many total outfit options does Daniela have? Well, when things are related, okay, and we're checking on probability, we can multiply. So she's got 2 options for tops times 2 options for jackets times 2 options for shoes. So she has a total of 6 outfit options. 2 tops, 2 different jackets, 2 different shoes. Okay? So what is the probability that Daniela chooses her polo? Well, her probability that she chooses her polo is just asking about her top. This is just our type over total. She has 2 total options for shirts. So 2 total options for shirts. One of those options is a polo. So she has a 1 out of 2 chance of choosing the polo. Okay, next one says Daniela chooses her polo and her hoodie. So we're now making 2 choices here on 2 separate events. Her odds of choosing her polo are 1 out of 2. We already determined that. Her odds of choosing a jacket or choosing a hoodie is 1 out of 2 possible jackets. 2 related events, we're going to multiply those together. 1 times 1 is 1. 2 times 2 is 4. So her odds or her probability of choosing a polo and then her hoodie are 1 out of 4. Very last one, Daniela chooses her, or what is the probability that Daniela chooses her polo, her hoodie, and her Vans? So we already said it's a 1 in 2 that she chooses her polo, times a 1 in 2 of her choosing her hoodie, times a 1 in 2, oh, you can't see that up there, times a 1 in 2 of her choosing her Vans. So she got a 1 in 2 chance of choosing the polo, a 1 in 2 chance of choosing the hoodie, and then a 1 in 2 chance of choosing the shoes. So times another 1 over 2. 1 times 1 times 1 is 1. 2 times 2 is 4 times 2 is 8. She has a 1 out of 8 chance, and I just realized I made a mistake here. 2 times 2 times 2 is 8, not 6. I added them and did not multiply them. So I made a mistake here. 2 times 2 times 2 should be 8, not 6. Sorry, guys, math is hard sometimes, and it's okay to make mistakes. That's mostly what I want to say. Okay? That pretty much wraps up your tree and Venn diagrams. If you have any questions on this, please let me know. At this point, you are going to pause and practice and complete the second and third sheets in your packet. So pause and practice now. When you are finished, you will see this page. When you are finished, we're going to get to this page and go over some of these before you do some more pause and practice. Okay, we looked at visualizing probability. Now we're going to look at the 3 different types of probability we've learned about. We've kind of already talked about these with our tree and Venn diagrams, but just to formalize these, simple probability is a single event. So one thing out of a bag. I draw a die one time. It doesn't depend on anything else. It is a single event. It is always our type out of total. Single event, always our type out of total. Independent probability is 2 or more related events. Okay? This is our with replacement. Okay, this is with replacement. The 2 events are independent of each other. They're related, but they're independent of each other, okay? With replacement, this means your total does not change. So your total does not change. And we're using multiplication between the events because they are related. Dependent probability is very, very similar. It has to do with 2 or more related events. However, dependent probability is our without replacement. The events depend on each other. Here, your total does change, because we're not replacing whatever item we drew or took away, but it does also use multiplication. Okay, so now that we know our definitions of simple probability, independent probability, and dependent probability, let's look at a few examples of how we see these actually play out. So simple probability, if I read this problem, it says if you rolled a die once, what is the probability you land on a 3? If I have a 6-sided die here, okay, I know that this is a single event because I'm rolling it one time. It's a single event. So I'm looking for type out of total. Okay, if I'm looking at my die, I only have one side on it that has a 3. So I know my type is 1 because there's only one side of my die that has a 3 on it. Out of total, well, the total sides of my die, or the total number on it, is 6. So I have a 1 in 6 chance of rolling a 3. See if it happens. No, rolled a 1. No, it's only a 1 in 6 chance. Okay, if you rolled a die once, so again, once, we know that this is our simple probability because it's a single event. What is the probability it will not land on a 4? This is a really, really important word here. Not usually means subtraction. Okay, not usually means subtraction. So if I'm looking at this, okay, I know my odds of actually rolling a 4 are 1 in 6. Okay, but I can't use the side that has 4 on it. So how many sides do I have left over? Well, I have 1, 2, 3, 4, 5 sides left over. Okay, because I cannot roll a 4, but there are 1, 2, 3, 4, 5 other sides that I can. So my probability of not rolling a 4 is 5 out of 6. See how the actual experimental probability goes. I rolled a 2. So I rolled not a 4. Mine checked out there. Okay, next one is independent probability. 2 or more related events, the total does not change. Okay, so this says there are 8 marbles in a bag, so that's my total. There are 5 green marbles, 2 red marbles, and 1 blue marble. With replacement, this is really, really important. With replacement means our total does not change. What is the probability you draw a green marble and then a red marble? So let's focus on the green marble first. I know that I have a 5 in 8 chance of drawing a green marble because there's 5 green marbles out of the total of 8. I'm going to zoom in a tiny bit on this. Okay. Then what's my probability of drawing a red marble? With replacement, so my total does not change. There are 2 red marbles in my bag, so it would be 2 out of 8. 2 related events, I'm going to multiply these together. 5 times 2 is 10. 8 times 8 is 64. If I pop that in my calculator, I get that to reduce down to 5 out of 32. Excuse me. So this one is with replacement, so our total does not change. Okay, let's look at this second problem. It's very, very similar, but with one key point here. There are 8 marbles in a bag. There are 5 green marbles, 2 red marbles, and 3 blue marbles. Without replacement, what is the probability you draw a blue and then a green marble? Key phrase here, without replacement. That means my total is going to change. Okay, so first let's start with the probability I draw a blue. Well, there are 3 blue marbles in the bag, so there is a 3 out of 8 type over total, green over total, chance that I draw a, blue marble. 3 out of 8 chance I draw a blue marble, then a green marble. Okay, so I know they're related events, so I'm going to multiply them here. I took out 1 blue marble. If I had 8 marbles and I took away 1 blue one, my new total is going to be 7. There is now 1 less marble in the bag. Okay, now how many green marbles do I have left over? I have 5 green marbles left over, so I have a 5 out of 7 chance of picking a green marble. Okay, 5 times 3 is 15. 8 times 7 is 56, right? Yeah, wow, doubted myself there for a second. Okay, 15 out of 56, let's see if that reduces. It does not, so that is my final answer. Okay, so simple probability, single event, type over total. Independent is with replacement, dependent is without replacement. Okay, what you are going to do next, you are going to pause and practice and finish this section and this section of practice problems, and then that will bring us to our quiz. Check your answers on the board as you work. That is all I have. Like and subscribe.